Hi, I'm Kelly from RStudio Solutions Engineering. On this episode of the SolEng Cast, you'll get to hear my colleague James Blair talk about RStudio 1.2 and local background jobs.
To start with, as Nathan mentioned, we've got kind of this grid outline. Nathan actually created this, and I like the breakdown here because there's kind of two different notions, and I want to make sure that we're clear about the two different tools that we're talking about in our discussion today. So there's the local jobs option, or the local jobs feature, and that's available in all RStudio products. So RStudio Desktop, RStudio Server, RStudio Server Pro, open source Pro version, all of those have the local jobs feature. And what that essentially does is that allows you to start any R script as a background process that allows your current R session to remain free, so that you can, right? And we'll look at what that looks like in some demos in just a moment. The other piece is the launcher, which is restricted to RStudio Server Pro, where you can do a couple of things. One is you can start a session that's managed remotely. So you can start an R session that's detached from the server where RStudio Server Pro is running. And that session is managed right now. Kubernetes is what we support, but there's support coming for Slurm and other resource managers. But the idea is that that R session is living and being interacted with remotely. It's being managed by some other infrastructure that the organization is set up and connected to RStudio. The other thing that you can do, in addition to interactive sessions, is very much like local jobs. You can start an arbitrary R script as a remote job that then runs in this external resource manager. So the difference is a local job runs on the same machine that you're currently on. A launcher job runs in the background on a different machine, right, in some other resource management system. Excellent. So I want to share, there's a repository that's a work in progress right now that hopefully will highlight these different use cases, or some general use cases around these. Now, these are not meant to be like, hey, you know, totally blow your socks off, this is overly complicated. These are meant to be, let's get the wheels turning on how you might utilize some of these tools that exist. And so this is the repository. It's just called Background Jobs. And this highlights, and I'll go through a couple of demos here, but this highlights using both the local background jobs feature as well as the launcher background jobs feature. There's a couple of use cases that I think are very well suited to local jobs. In fact, they're use cases that I've adopted in my own workflow and use quite frequently. And so one of those is you can develop a Shiny application, right? So we're all well familiar and happy with Shiny. You can be working on a Shiny application, and typically the workflow is I work on my app, I click Run App in the top, I check my progress, I close the app, I make some changes, I click Run App, I check my progress, I close the app, I make some changes, right? That's kind of the typical workflow that happens. With background jobs, you can actually do something pretty interesting, and that is you can start the application as a background job and then view edits and updates to the source code in real time. And so to show you what this looks like, and this link here will take you to a subdirectory in this repository that kind of highlights how you can do that. There's a little screen capture here of what this looks like. But just to show this in kind of real time. So this is just the Hello World Shiny application, right? Just our usual friendly histogram. A Shiny application, whenever you click Run App, if I just do this here in RStudio Server Pro, I get the nice little pop-up that shows me the application. But then you'll notice that that button actually ran this Shiny Run App function, right? So it calls this function on the source code of my application, and that's what causes Shiny to start running. So what we need to do in order to run this in the background is we create this little helper script. And again, this is outlined in the repository. But this little helper script, all this does is it does two things. It sets the Shiny auto reload option to be true. And so this tells Shiny to listen for changes in the source code and automatically refresh the app if anything changes. And then it just calls Shiny run app. And since this is from the same working directory as the Shiny application, if I come down here to jobs and click start local job, then I get this little dialog box that shows me the job. And there's several different options. Jonathan McPherson did a great blog post that's linked in the repository around kind of the options that exist. And we'll, in some of the examples that are forthcoming, we'll highlight some of these options. But for this use case, there's not anything that needs to be adjusted here. It identifies the active R script as the R script that's going to be run. It identifies the working directory as the directory that contains that R script, which is what I want in this case. And now if I hit start, then it gives me this little output here. It says, this is the typical message that we see when we're starting a Shiny application. But notice it's running in this jobs pane, and it shows me the URL that this Shiny application is being served on. Now, in RStudio Server Pro, I can't just like copy this URL and paste it into a new tab in my browser, because this URL is referencing something on localhost, which is native to this particular RStudio Server machine. But what I can do, and this is pretty interesting, is if I come back to the console, notice I still have a live active R session here. I can use the RStudio API package, and then there's a viewer function. And if I paste in, oops, let's try that again. If I copy and paste in the URL for my application, then the application will open in the viewer pane. And so now I've got this application that's running in the background, but I have access to it in RStudio, like I almost would expect to when I click, run app in a normal context. But now if I come back to the application and make some sort of a change, right? So updated title and save this, then this application automatically reloads and reflects that updated change. And so now we have this nice workflow where I can run this application in the background, and then I can just be editing and making updates to the UI, or I can be tweaking things to see how they're impacting the application itself. And all of the changes are being reflected in real time. And again, this is a feature that works best in local jobs. So this is a workflow that can work on the desktop, in RStudio Server open source, and RStudio Server Pro, kind of across the board. What's happening is this is being supported by a background R session, right? So if I come over to jobs, this job is ongoing. I can see that this job is in progress because it's just running. This is supporting the Shiny runtime. And then I have this separate R session that was the session that I started with, and it's still interactive. And so now I can come in here and I can make changes. I can continue to work kind of as normal. I can experiment with things in the console, right? I have a fully active, fully available R session, but then I also have the ability to see and interact with my Shiny app over here on the side. That's being supported by that background job. This will work on RStudio Desktop. This will work on the open source version of RStudio Server. This is using the local jobs feature, which is an open source feature, right? So I could start up RStudio again or start another session, start the Shiny application there, come back to this session. This just kind of keeps everything in a nice, neat bundle in a way that's a fairly straightforward workflow. Just to showcase this, if I go to try to restart my R session, I'll get this message that says, look, you have a job that's still running, because whenever my R session terminates, any associated local jobs will automatically also terminate. And so this will alert me to let me know that I have a local job that's running, and then I can choose whether I want to manually do something with that or just automatically terminate it in order to restart the session. Okay, so there's local jobs. What I want to highlight next, and this is where we're kind of building out some additional examples. Let's say that you have some sort of like long-running process, right? So for example, maybe you have some sort of simulation that takes a little while to run, and you want to send that into the background. And in this example, we have a script here that just estimates the value of pi using a Monte Carlo simulation. So we generate all these data points, then we check to see whether or not they're within the circle, and use that as a rough estimate of the value of pi. And then what's cool about this is you can actually do additional things, like you can, within your job, you can have it save results intermittently out to a specific location. And so in this case, I go through and I generate these random points, and then every 25th point, I save out all the cumulative points that have been generated up until that point to a specific file that I could then go and query and read. And so I can start this as a local job, right? I can say, okay, let's do this. Start this as a local job, and then this will get going. Let's create my directory really quick. All right, try this again. One other thing that I'll make note of here is you can start local jobs down here in the Start Local Job tab in the Jobs pane. You can also source files as a local job script. So if I come up here to Source, click on this drop down, you'll see that I have the option to source this as a local job, right? So source this as a local job. Same dialog pops up. I get the same options. If I hit Start, you'll notice that I have some code in my script that writes out these messages, right? So saving results. Here's the estimate of pi at that point. And if I come into this output directory, I'll see the results of this particular simulation. Now what's cool, and Nathan mentioned this earlier, is I can come back here and I can say, well, maybe I want to run this multiple times for some reason, or I have multiple jobs that I want to run. Let's come start this again as a new local job. And if I come back over here, now I have 2 local jobs running. My current R session is still free to do whatever I want, right? Well, I haven't tied myself up here. And then you'll notice over here on the right-hand side, both of these files are being updated and are growing as those local jobs continue to save data out to these. And so I could read these files in if I wanted to check on the progress, right? Or I could do something like this, or I could do something with these files as they're being updated. And this can be a good pattern for long-running simulations like this, as well as things like if I've got an API that I'm querying that's rate limited or that takes a while to respond, I can have that request happening in the background while I'm doing something else with my active R session, right? The local jobs functionality is really meant for these kind of like one-off type workflows, right? I've got something, oh, I've written a script, right? And I think it's going to take a while. Boom, it's running in the background. It's fairly easy to just ship this to the background and do some things. There's some additional options here. So let me just show this again. If I come up and want to send something into the background, right? Source is a local job. You can just identify what script you want to run, the working directory of that script, but then you also have these environment options. So I have a couple things I can do. I can run the job with a copy of my global environment, meaning I can just ship everything that exists in my current R session into this new R session, which can be helpful in some contexts. And then I can also choose what to do with the results of the job. By default, they just get obliterated, right? So if the job doesn't save anything out, then there's no real permanent record or any like end result of that job per se. But I could also just copy all the results to my global environment, which would mean that anything that was instantiated and created in the job at the conclusion of the job would automatically show up in my global environment. There's a caveat there that says, if you create an object of the same name in your job as an object that currently exists in your global environment, it will be, the job output will overwrite your current environment without any warning. So to be aware of that.
Wow.
And then the other option here is I can save the results as an environment, which means that once the script is done running, I'll have an environment object that's been created in my global R session that's just called, I think it by default is the name of the script that was run followed by environment. And I can then access any objects within that environment. That keeps the results of my job separate from my global environment by instantiating them in separate environments. But I have some options there. This is really useful for kind of one-off things. I think the Shiny use case, the Plumber use case that we demonstrated, it can be really useful workflows. If you're trying to programmatically distribute things, something like Caller or something like an established kind of parallelization framework is a better option, right? But certainly for kind of ad hoc, I want to send this job into the background so I can do something else for a minute, is certainly kind of the use case that they have in mind with local jobs.
Thanks for listening to this episode of the SolEng cast from RStudio. If you enjoyed this episode, please share your thoughts and questions with us on the episode show notes page found at community.rstudio.com in the R Admins forum.